For this question, we have a picture of a quadratic function on the right, and we have some questions about this quadratic function. We want to know, is the leading coefficient positive or negative? What is the value of h? What is the value of k? What is the value of the leading coefficient a? Then we want to write the equation of the function in vertex form, which is given here, and write the equation of the function in general form, which is given here. And what we want to take notice of is that a couple points have been marked for us. This point here is the ordered pair 4, 5, and it's marked right here. This is a special point on the graph. This is the vertex. And we label the vertex with the ordered pair HK in our formulas. And then we're given another point on our graph, and this point is the ordered pair 5, 9. And it does not have any special notation. It is just some ordered pair that is on the graph of this particular function. So let's go through the questions with this information. So the first question says, is the leading coefficient positive or negative? Now, we're looking at this graph, we can see that this parabola is oriented up. So because that parabola is oriented up, we know that our leading coefficient A is going to be greater than 0 or positive. So by the orientation of our parabola, we know that A, our leading coefficient, is positive. In the next question, it says, what is the value of h and what is the value of k? So we're talking about our vertex, and our vertex was labeled on the graph with 4, 5, and so h is 4 and k is 5. So we know the value of our h and k, which is the vertex of our parabola. In part C, we want to find the value of the leading coefficient. So this is going to require some more work, in fact, solving an equation. So our strategy for this is to start off with the vertex form. F of x is equal to a times x minus h squared plus k. And we have the value of h, and we have the value of k. We're hoping to figure out the value of a. Now we also have this ordered pair, 5, 9, and we're going to use that as an x and a y. This is the x, and f of x is the same thing as y. So we have values to substitute for all the variables except for the one that we're trying to solve for. So we're going to be able to substitute those numbers in and solve for the value of a. So substituting those values in, we'll get 9 equals a times 5 minus 4 squared plus 5. So remember that this is the h and k here and here. And then we have our x and y, and that's how we substituted into our equation. So we're going to simplify, and we have 9 equals a times 5 minus 4, that's a 1, and 1 squared is 1, so we have a times 1 plus 5 on the right, and a times 1 is a, so we have a plus 5 on the right, and we can solve for a by subtracting 5. That gives a equals 4. So now we know that value of a, our leading coefficient, is 4. In the next part, we want to write the equation in vertex form. To write the equation in vertex form, we just need to substitute the value of a that we just found, the h, and the k that we had earlier. So in vertex form, we're going to have f of x equals 4 times x minus 4 squared plus 5. So that is the equation of our function in vertex form. In our final part, we want to write the function in general form, which is our expanded form, f of x equals ax squared plus bx plus c. So to write it in this expanded form, we're going to take our vertex form and do a bunch of algebraic simplification. So we're going to apply that exponent. That's x minus 4 times x minus 4. We're going to multiply out those binomials to get x squared minus 4x plus 16. Carry down that plus 5. I'm going to simplify inside the parentheses by combining like terms. Negative 4x minus 4x is a negative 8x. And I'll distribute the 4. That gives 4x squared minus 32x. And let's see, 16 times 4 is going to be 64. And I'll combine like terms. 64 plus 5 is 69. So now we have our general form of the quadratic function being f of x equals 4x squared minus 32x plus 69. The graph to the right was created by using one horizontal shift and one vertical shift of the graph of the basic function y equals absolute value of x. Write the function that describes the graph to the right. So we are given this particular graph of an absolute value function, and we want to write the equation of that function using one horizontal shift and one vertical shift. So it's helpful if we know what the original graph looks like. Y equals absolute value of x does have this V shape that our picture does, but the turning point that we see here, really it's like a corner where the two lines meet each other. That corner is happening at the origin, which is at 0, 0. So if we pay attention to that corner and where the new corner is, that's going to be helpful in understanding what our vertical and horizontal shift are going to be. So what we notice is that from our origin, this new point is shifted to the left 1 unit and down 3 units. And so we want to make sure that our equation reflects that shift, that horizontal shift of left 1 and the vertical shift of going down 3. Now, in order for us to know what the equation looks like, we'll have had to study horizontal shifts and vertical shifts and have some facts memorized. So what I did is I pulled up this flowchart that I created to help us memorize the information that we need to know about shifts in order to write our equation. So one thing that we need to know is that in our equation, the shifts are going to be added and subtracted numbers. And then vertical shifts are going to be added on the outside, and horizontal shifts are going to be added on the inside. So our horizontal shift is going to shift to the left, which means that we're going to add our 1. Remember, it was 1 unit to the left. And our vertical shift is a shift down, so we're going to subtract by 3 to shift down 3 units. So that down 3, that subtraction is going to be on the outside because it's a vertical, and plus 1 is going to be on the inside of the absolute value because this is a horizontal shift. So let's go back to our problem, go back to our picture. And our base equation is absolute value. And on the inside, we want to do our horizontal shift, which we're going to do a plus 1 to do a shift to the left 1. And our vertical shift is going to be on the outside, and it's going to go down 3, so we subtract. So this is our horizontal shift, and this is our vertical shift. And this is our equation of the graph that we have on the right. Absolute value of x plus 1 minus 3. So given the quadratic function, f of x equals 2x squared minus 11x minus 9, and we want to address the following. Does the function have a maximum or minimum value? And what is that maximum or minimum value? So because we are dealing with a quadratic function, we can tell whether we have a maximum or minimum value by the orientation of our parabola. So looking at this quadratic function, the value of a is always attached to the squared term. So our a is equal to 2, and that is a positive value greater than 0. And because of that, the orientation of the parabola is going to be up. The parabola is an up-facing parabola. And so this quadratic function will have a minimum value at the vertex. So it's got the y value being the lowest at the vertex. So we can say that this function has a minimum value because the orientation is up. And then we can find that minimum or maximum value by finding the vertex. I'm going to find the vertex with the vertex formula. And the vertex formula is negative b over 2a. You'll have to excuse me, I should write this as and h. We usually label our vertex as hk. So our formula for the vertex is negative b over 2a. The value of b is negative 11, and the value of c is negative 9. So when we're finding this vertex, we're going to substitute into the formula. That gives negative 11. So I'm using the negative from the formula, and the number is negative, so I want to make sure that I include both of those negatives. Sometimes we forget that. We have 2 times a which is 2. So we have our h being positive 11 over 4. So then we're going to find the y part of our vertex. And to find that y part of the vertex, I'm going to substitute the x into the function. So I'm doing f of h, and we just found h. So that's f of 11 over 4. So in this example, we would have 2 times 11 over 4 squared minus 11 times 11 over 4 minus 9. So we're going to have to be really careful with our arithmetic here since we have fractions. So 11 over 4 squared would be 121 over 16. And 11 times 11, that's 121 over 4 minus 9. And then I can reduce this fraction a little bit because the 2 will cancel with that 16. So I have 121 over 8 minus 121 over 4 minus 9. And to combine these together, I would need a common denominator. So I'm going to multiply the 121 over 4 by 2 over 2 to create a common denominator of 8. And I'll multiply the 9 by 8 over 8 to create that common denominator of 8. That's going to give 121 over 8 minus 242 over 8 minus 72 over 8. The 121 over 8 minus 242 over 8 will be negative 121 over 8 minus 72 over 8. And negative 121 minus 72 would give me a negative 193 over 8. And the minimum or maximum value will be the y part of our vertex. So the negative 193 over 8 is our minimum value. Now you could also use your calculator and get a decimal approximation for this. So let me bring my calculator up. And I've got this calculator here that I've downloaded. And it's got a negative 193 over 8. And that gives me a negative 24.125. And both of these answers are valid, but you just want to pay attention to the directions to see if any details were given on how the answer should be written. I noticed I didn't have it pasted on the screen here, but I noticed that in the directions it said to write a integer or simplified fraction. So this is the answer that would be accepted by the computer system. For this question, we want to use the graph to determine the domain and range of the function. We have this picture, and a couple little things I want to point out before we go over the details. We are going to assume that, I'm going to use blue because our graph here is blue. I'm going to assume that these lines have arrows on the end of them, meaning that the pattern continues even after what we're seeing on this picture. And especially because we're looking for the domain and range, we would need to know if this line stops or not. So I'm going to assume that it continues on. So I'm drawing those arrows on the end. So we want to find the domain and the range. Now the definition of the domain is that it's going to be the set of all the x's, all the first coordinates, and the range is the set of all y's or second coordinates of the graph. Our x scale is the horizontal scale. Our y scale is the vertical scale. So I'm going to get my ruler out because I find that the ruler is really helpful in finding domain. And when we're finding domain, I like to hold it up vertically. And because vertically, this ruler is sort of pointing to an x along the graph. So this is going to help me get the interval notation of our function here. So with the domain, because of that arrow that we see on the end, it means that the line will continue moving down and to the left and down and to the left on forever. So that means that our domain is going to start at negative infinity. And what I'm thinking of as I hold the ruler up here is, when is my ruler touching the graph? So because that arrow means it goes on forever, it begins touching it at negative infinity. Now negative infinity is not a number, it's an idea that it goes on forever. So that's where our domain starts. And I am touching the graph all along these x values. And when I get to this dotted line, I have to know what that dotted line is. That is a vertical asymptote. And this particular vertical asymptote is at x equals, looks like -3. So on this portion of the line up here, the graph is getting closer to that dotted line without ever touching it. So because we never touch that dotted line, we have a break in our domain. So our domain is going to stop at that -3. Then right on the other side of the line, you can see that we have another line with an arrow. And that side of the line is going to get closer and closer without ever touching it. So our domain is going to continue right after the -3. And it goes on and on until infinity. So the ruler is touching the graph for the remainder of the time. So I've written this in interval notation, but there's another notation that can be used, and it's called set builder notation. And with set builder notation, we would write a curly brace, and we would say that our domain consists of x's, and then we write this vertical bar. This vertical bar is, we say it as the words such that, but after that vertical bar, we have the conditions, or you could think of them as rules for what is in the set or what is not in the set. So the rules are, the only rule that we came up with is that -3 is not part of the domain. So we can say that x is not equal to -3, and the meaning of this is now that this set contains all real numbers except -3. So that's a different way to write the set in set builder notation. So then I want to find the range. And when I'm finding the range, I'm going to use my ruler horizontally. because it's pointing to the y scale, and it's going to help me see which y's are part of the graph. So down here at the bottom, I don't see any part of the graph, so none of these y values are going to be included in the range. So it's not until we get to this spot right here, and it's not really labeled on our picture, but I can tell by how the graph is drawn. On this portion of the graph, x is approaching negative infinity and y is approaching 0. And on this portion of the graph, x is approaching infinity and y is approaching 0. And this is the definition of a horizontal asymptote. This horizontal asymptote is sitting right on top of the x-axis. So this graph has a horizontal asymptote at y equals 0. So what that means is that our y is getting closer and closer to 0 without ever reaching it. So our range is going to start at 0. Our range in interval notation starts at 0. Because the graph never reaches 0, we're going to put a parenthesis on that 0. And then all of these y values that are above the x-axis are included in the range. So from 0 to infinity is our range. Now that's using interval notation. If I want to use the set builder notation, I would now write my curly braces, and since we're talking about the range, I'm going to use the letter y such that, and my y values are all greater than 0. So y such that y is greater than 0, so this is all real numbers that are greater than 0. So that's in our set builder notation. So we have the domain being all real numbers except for -3, and the range being all real numbers that are greater than 0. On this question, we are given a graph that we see here on the left, and we want to use this graph to find the vertical asymptotes of the function. So what I did here is I pulled up from our notes the definition of the vertical asymptote. The line x equals a is a vertical asymptote of the graph of a function f if f of x increases or decreases without bound as x approaches a. Symbolically, if f of x approaches infinity or f of x approaches negative infinity as x approaches a, then x equals a is a vertical asymptote. So when we're looking on a graph for vertical asymptotes, we're looking for y to increase or decrease without bound. That means we're looking for y to approach infinity or y to approach negative infinity. So we've got our y scale, which is this vertical scale here. And remember, infinity is way up here and negative infinity is way down here. So on our graph, we're looking for the parts of the graph that are either going to infinity or negative infinity. So on our picture, right here, those two pieces of the line, we have the y approaching infinity here, and the y approaching infinity on this side as well. And both of them have x approaching where this dashed line is marked. They have x approaching -5 on this side. We use a little plus sign when it's above the number. and x is approaching -5. From below the number, we use that minus sign when we're below. So on this graph, because y is approaching infinity, as x is approaching -5, we can say that the graph has a vertical asymptote at x equals -5. So that's the location of our vertical asymptote. We want to use the quadratic function f of x equals -1/5 x squared plus 6x minus 1 to address the following questions. We want to use the vertex formula to determine the vertex. We want to decide whether the graph opens up or down. I call this the orientation of the graph. And also state what the equation of the axis of symmetry is. So our quadratic function is in general form f of x equals -1/5 x squared plus 6x minus 1. The value of a is always attached to our squared term, so that's a -1/5. The value of b is attached to our linear term, which is 6, and our constant is -1, which is c. So we are going to use the vertex formula to find the vertex, and the vertex formula has an ordered pair, hk, and we're going to find the x-coordinate of the vertex using the formula -b/2a. And we're going to find the y part of our vertex by plugging that h into our function. So we're plugging the x into the function to get the y. So for the h part of our vertex, we're going to do -6 over 2 times -1/5. The -6 over -2/5. When we divide fractions, let's write it as division first. We've got -6 divided by -2/5. We're going to multiply by the reciprocal, so that gives -6 times -5/2. So when we multiply, that's going to give -30/2, which simplifies to be -15. Oops. Yeah, oh, that's good. So we have -15 for our value of h, the x-coordinate of our vertex. Then we're going to figure out k, which is the y value of our vertex, by substituting that into our function. So we're doing f of -15. That's -1/5 times -15 squared plus 6 times -15 minus 1. I have -1/5 times 15 squared. I'm going to multiply that over here. So we've got a positive 225 for -15 squared, and then 6 times -15, that's going to be a negative, and that should be 90 minus 1. And 5 divided into 225, let's see, 5 divided into 225, will go in there 45 times. So we get -45 minus 90 minus 1. And that gives a -90 and 45. The negative 135 minus 1, that's negative 134. So as I was doing that math, I got the feeling that I had made a mistake because I don't know if any reason why, but this always seems to come out to be this number being half of this number, and when we put them together, this becomes the other half. And so that pattern I've seen in a lot of math problems that I've done, and it wasn't fitting, so I thought maybe I made a mistake. So I did make a mistake, and let's go back up here to see where the mistake is. Up here I have a negative 6 multiplied by a negative 5 over 2, and that should have been a positive right there. So I was a little bit careless that should have been a positive 30 over 2, which is a positive 15. So I'm going to make these corrections. This should be a positive 15. That does not change this number right here because negative 15 squared and positive 15 squared are both 225. But if we change this right here to a plus, that's going to change this to a positive 90, and it will change this up. So let me go ahead and correct that. So now we have a negative 45 plus 90 minus 1, and that should be a positive 45 minus 1, and we get 44. So now we found the vertex to be 15, 44, and we want to know the orientation. Does this graph open up or open down? We can determine that with the value of A. So because A is negative 1/5, which is less than 0, we know that the orientation is open down. So the graph of this parabola will open down. So finally, we want to know what the axis of symmetry is. And with parabolas, the graph does have some symmetry going around the vertex. And so we call the vertical line that passes through the vertex the axis of symmetry. And it's a vertical line, and the equation of a vertical line is always x equals. And we're going to use that x coordinate from the vertex because the symmetry is around the vertex. So our vertical line, which is the axis of symmetry, is x equals 15. On this question, we want to evaluate f over g of 0, given that f of x is equal to the square root of x plus 9, and g of x is equal to x squared minus 3. I have two different approaches that we can take to evaluating this function. So I like to use the phrase build then plug or plug then build, and that describes the two different ways that we're going to do this. So one way is to build then plug, and the other way is to plug then build. And this is really following the symbols the second way. So using the first method, what I mean by build is to build the function that is described in the name. So we want to build the function f over g of x. The function that's in the name is descriptive of how to build the function. So we want to take a function named f of x and divide it by a function named g of x. And we're given that f of x and g of x. So f of x is the square root of x plus 9. G of x is x squared minus 3. So we've built the function that's been described. Then we're going to do the plug. If you don't like that word, you can use substitution. So maybe build then sub. So we're going to substitute or plug in that 0 in for x. So that's going to give square root of 0 plus 9 over 0 squared minus 3. That's square root of 9 over 0 squared is 0 minus 3, that's negative 3. Square root of 9 is 3, and 3 divided by negative 3 is negative 1. So we were able to get that f divided by g of 0 is negative 1. So that's the first way. So the second way to do it is to plug, then build. So let me describe exactly what that means. We have f over g of 0. So when we plug, what we're going to do is we're going to plug a 0 into f, and we're going to plug a 0 into g. So that's plugging first. And then to build, we're going to follow what the name of the function is. We're going to divide our answers. So we're going to do f of 0 and g of 0. That takes care of the plugging. And then we're going to divide those answers, and that takes care of the building part. So if we do f of 0, that's square root of 0 plus 9. And g of 0 is 0 squared minus 3. And notice I've put them in a fraction, so we can do that division. So we have square root of 9 over negative 3. Square root of 9 is 3. Divided by negative 3 will give us that negative 1. So two different approaches to evaluate f over g of 0. Thank you for checking out my videos. Have a great day.